Again, if we want to talk about how logarithms behave, there are a lot of unique and unusual behaviors that we get, which we'll see more of in the next section. But for the most basic, fundamental ones you absolutely have to have some understanding of that you're going to be using the most often, just remember, everything we have here comes from exponents. It all comes from exponential behaviors because these are the reverse. These are about identifying exponents. So, works in the way you might hope, works in the way you might expect if you're comfortable with those exponential things. Maybe you're not there yet, but you'll get there, and this stuff will make more sense as you get more context. But here, we have that log base b of b is equal to 1, because what this question asks, log base b of b, is what power of b is b itself? The first one. Then we have that log base b of 1 is equal to 0, because again, this question asks what power of some number b gets you 1? Well, that's the 0th power. That's the importance of the 0th power there. And then over here, if we have log base b of b raised to the power x, that just says remove the b's. Identify the exponent there is just x. So if we have, on the other hand, b raised to the log b of x, which, yeah, it's a bit of a mouthful, but again, that has the same sort of cancellation property that we're killing off those b's along the way because they're doing opposites of each other, just like when you evaluate inverses at each other, you end up with the identity. All of this stuff works because the entire definition for how we use logarithms today is in relation to exponential things. So if you're doing something exponential, the logarithm undoes something exponential. If you have a term that has a natural exponential thing you can identify, it's careful to say that because we're not talking about e just yet, but the point is, it does what you should hope for. So we're going to take a couple more quick examples here to see this in the context of some specific numbers, not just the letter b a whole bunch of times. So for this example, we want to simplify the expressions log base 4 of 4, log base 4,301 of 1, log base 4 of 4 to the 7th, and 8 raised to the power log 8 of 2. So, a lot of these look pretty terrifying, a lot of these look pretty nuanced. Don't worry so much, they're not actually as bad as they might appear. In that first case, what we're looking at is an example of this idea here, that we're taking log base b of itself. So, log base 4 of 4 asks us to identify what power of 4 is 4. It's the first power. Then for that second one, I picked a really obnoxious looking base there, log base 4,301, because it doesn't really matter. If we're asking to find that evaluated at 1, we're saying what power of that 4,301 is 1? Who cares? 0. Then in case 3, we're doing something with the exponent, so log base 4 of 4 raised to the 7th power. Again, logarithms are meant specifically to identify the power of the exponent here. If we have 4, we want to find out how many times we've raised 4 to get 4 to the 7th. Hey, 7. Don't overthink it. And then finally, for that last case, we're going in the other sort of inverse relationship. There we have the messy looking term 8 log 8 of 2, which, again, we're saying what power of 8 is 2, but that's already in the exponent. Again, those things are inverses of each other, so they kind of kill each other, and we're left with just 2. And the fun thing about stuff like this is you can, if you want to confuse your friends, make your friends feel bad about how little math they know, you can write some really nasty expressions with these sort of things that are always just 1 because of their nice logarithmic and exponential cancellation properties. It works out into prettier patterns, or at the very least smaller patterns than they might initially appear. Anyway, these are our basic properties, so now that we have some better sense of how logarithms act, let's take a look at how logarithms can be graphed, where, again, just like with exponentials, we're not going to be worried so much about the really complex and weird points. We're going to focus on the more approachable ones and fill in the blanks, and in particular, we're going to use the fact that instead of having to worry about powers of oddball things, just reverse it. Use exponentials, because exponentials are inverses, and, well, if we have one function, graphing its inverse might not be easy, but it's a little bit more manageable.